Hello, my name is Ryan Steer with the BLDC Motor Senior Design Group SD 2026, and I'm going to show you how our code works for the small motor. We are using the module RPi.GPIO for generating the signal that goes to the ESC, and we are using BlueDot so that we can connect to the Raspberry Pi via Bluetooth using the app BlueDot on our phones. So first, we initialize the signal for the motor, and that's just so that we can start using the RPi.GPIO module, and then we actually send the initialization signal for the motor. So this is the sequence that we found to work for us. First we send a ground signal and asks for the battery to be disconnected. Once it's disconnected, we start sending a max speed signal, which is a 2 millisecond pulse width at 50 Hertz. The module that we're using automatically uses 50 Hertz for the frequency, and the number here that is sent to, or that is passed to the function set servo pulse width is the time of the pulse width in microseconds. And so after we send in the max speed signal, we ask for the battery to be connected. This doesn't actually turn on the motor at max speed, but it does start beeping pretty loudly because it's not yet initialized. Once the battery is connected, then we send in a minSpeed, which is a 0.7 millisecond pulse width for 2 seconds. And then we send in a zero signal, ground signal, for 2 seconds, minSpeed again for 1 second, and then a neutral signal for, and then the motor will then be initialized. So a pulse width of 1.5 milliseconds actually stops the motor. Sending a value above 1500 will then start spinning the motor, and a value below 1500 will spin the motor in reverse. So once we have our motor initialized, we then initialize the Bluetooth connection with BlueDot, and this starts instance of the app with one column with 2 buttons. And once the phone is connected, then we can start polling for input for the buttons. So the top button is a slider. Once the button is pressed in the center, it'll call the update speed function whenever that button is touched. And this function will automatically pass a position value, and this is a number between 0 and 1. So touching the center of the button will pass a 0, and touching the outside edge of the button will pass a 1. And then it scales naturally anywhere that you touch in between. So we then scale that 0 to 1 value based off of the input that we need for our motor. So touching the center of the button will pass a 1.5 millisecond pulse width, and then touching the outside edge will be our software limited max speed, which is about 1.55 milliseconds, which is plenty fast enough for demonstrating the motor. And then the second button is just a stop button, so that'll just pass a 1.5 millisecond pulse width to the motor, setting in the neutral, which stops it. It's essentially the same thing. And these two functions here, when they're called like this, they start their own thread in the process. So you're entirely capable of adding additional code below without actually impacting the control of the motors. And that's how the code works. Thank you.